one state branch of America. Okay? So that is in reference to stuff that we all bumped into. What happened is he saw that a joke was forming in the events we have all seen, and he applied it. Right. People laugh. Yeah. Like what? And I thought, yeah, it's like in AI, to be able to do culturally relevant things, we have to be culturally correct.
Right. It would pick up on some kids later. People who people, they have, they do a bunch of thinking different than the law. And they're very logical, but they're wrong.
Yeah, wrong. Another part of it is the amount of information going on is way over what you know. You're responding to a lot of information.
Wait, is it only the truly dedicated that stay on Sunday until 3? Should we?
And the ones who like to see an example of the Unikernel running.
Oh, okay, all right. We might deliver on that promise today. We'll, if each of you keep a finger crossed, I think we'll be good. Oh, beautiful. All right, well, we're just a couple minutes after. Welcome. Good. Yeah. So this is kind of reminds me of like grad school, where only the serious have like stuck around to do the extra work. So I sense I'm in the presence of some like-minded nerds. So this is good. Good. Well, we're going to talk about a few things today. One is unikernels in general, a little bit of an intro there, and then we're also going to talk about UniK, or a project called UniK, an open source project that is a bit like Docker is to containers. UniK is sort of like that to unikernels, except younger. So to the extent that we go through these, and if I go through anything too quickly, take a quick note of the URL. The slides are up there already, and so are a couple of other talks that I've given. So if you choose to suffer through more than the next 45 minutes, that's up to you.
You can't write that fast.
Oh, okay. Yeah. Let me go back real quick. Yeah. Oh, yeah. So while folks are writing that down, quick get to know you a little bit better. Is this who are we today? Are we Linux systems administrators generally, or are we developing? Are we operating? We're doing somewhere kind of all in the middle. Are we consulting and things? Okay. Very good. Okay. You will point out my mistakes today along with Brendan. So. Very good. Okay, good. Well, we'll have some fun. A little bit about me. I gave a talk earlier on Thursday, and I made the crack about this being my favorite subject, so I won't make that crack again, despite it being, not true. Anyway, I'm just so you guys have some background on me and can either believe or disbelieve things I'm about to tell you for the next 40-ish minutes. These are various activities that I'm into. I've been fairly container-oriented for the last 3 years. Was at Cisco at the time, kind of organized the Docker at Cisco community, and helped steward some new innovation projects there. And I've since went off to Seagate and did some cloudy things, did some things with OpenShift v3 with Kubernetes, and then I've just generally made myself a nuisance in organizing meetups out in Austin, some local conferences out in Austin. I am coming to you from Austin. I am still working on my Texas accent, if it doesn't come through, but it does occasionally. So harass me at will. It's a small enough audience. You guys will harass in person. If you don't, feel free to do it online. My full-time role is at SolarWinds. I've been there coming up on 7 months now, focused on technology strategy. So we've just got a small team of some bright folks working on innovation projects. So I thought I'd just ask real quick, folks, any of you guys familiar with SolarWinds software? SolarWinds? Yeah, got a healthy set of portfolios that I won't necessarily tell you about today, but they are very relevant to monitoring and management of infrastructure. Historically, sort of on-premises oriented, but has some some SaaS offerings out there as well. And so that cut short some of my other questions. Anybody suffer through the talk I gave on Thursday? Yeah, the guy didn't learn the first time, but I thought I'd quickly note, like, if to the extent that your containers can enter into your world, and if you're looking for maybe a free tool to understand what containers you're running in your environment and get some visibility to those, understand what network traffic is flowing between them, kind of the volume and direction of that traffic, maybe even do some bandwidth tests between them to test out, to verify the different types of network drivers that you're running and how performant they are. It's a very early tool, but could be beneficial, could be good to you. This is the part where I say, well, I guess where I ask the question. So into kernel development, but how many of you guys are new to unikernels as a topic? Very good. I am in excellent. You are in good company, I guess is what I would say. So I had said before, hey, I had a heavy focus on containers, and I'm just kind of making my journey into unikernel land. So we're going to do some of that today. And I thought I'd offer up this perspective. I think this is really my perspective that, I've had folks come up and say, well, hey, now that unikernels are here, I'm just going to skip containers and go right to those. And that may very well be true. Or, hey, my perspective is that it's really, our future is much more about sort of all of the above. That just as I think you guys were talking about container orchestrators and the choice there and trying to figure out which one is the right one, I, for one, while it's painful to figure out that choice, I'm glad that we've got choice of container orchestrator as well as just choice of different types of infrastructure, because these are just built for and work for different use cases, right? And it isn't a one-size-fits-all here. So my perspective is that we'll be living in a world where, where one or more of these are working in conjunction in the same environment, and we're going to see if I can't talk to you a little bit about that today and give you an example of that with UniK. So I'll say this, of the infrastructure that I just talked about, I'm not, depending upon what conversation you're having, I don't know that how much people that I would say that people consider infrastructure maybe a secondary concern. If we understand why it is that infrastructure, and this is probably not new to any of you, but just why are we running the infrastructure? It's to run the applications, it's to run the services. Maybe it's network services, maybe it's whatever those are. But so to the extent that people care about the application kind of becomes king and sort of center of focus. I tend to think that for some of the newer software development projects that are being made, those that are done in a continuously deliverable way, those that are done in a SaaS way, are often development-led, and it's often the developers as they're going in and defining that project that they end up defining the infrastructure as well. I think this is relevant to our talk in terms of them maybe electing for unikernels as the best for that particular application. Maybe not. I guess I'll risk this question. Just to the extent that the application is king, if that's true, or if we just assume that for a second, who would be the queen? That might be the developer. I don't know if that's sort of a tongue-in-cheek question there. So anyway, the developer, and not just the developer, the operators, everyone involved, the systems administrators, experience challenges with the way that we do applications today. I'm going to see if I can't enumerate these. We've got a challenge around fat systems that have been that have many layers to them. Not all of which I think we're going to see today, at least in a unikernel world, we don't necessarily need. If what I had said before is true about kind of having that central focus around applications, this is probably like, these are the things that are front and center and near and dear to the application. So is the rest, but our hope is with the promise of portability of containers and the portability of unikernels that some of these other layers become less and less potentially important. There's some other issues, challenges that we face today with the way that our applications are built and deployed. There's some inefficiencies. We've got long, this is a relative, I guess long is a relative adjective, and so a long time for VMs to start up, a long time for containers to start up in the face of unikernels. So we're talking like, maybe a couple of minutes with a VM, maybe less, probably, seconds with a container, and then getting into milliseconds with a unikernel. And that starts to change the game a little bit about how you're running your applications, how you're running your services. Our systems to date have been designed for, if you think about them, we've got general purpose operating systems that are multi-user. They're also multi-process and they're multi-application. They're built for, they're built with many users in mind. They're not necessarily built to run a specific application under a specific use case. We're going to start to contrast that against unikernels, which in fact are. Interestingly, a lot of the way in which we've developed software over time, that's certainly evolved, particularly I think just in the forefront of my mind is sort of the difference between on-premises kind of enterprise architected software, the way that that's downloaded and installed, versus continuously delivered SaaS software that's just iterated upon. And there's a significant difference in my mind, but I'll say that outside of that, the way that we package up our applications and deploy them hasn't necessarily changed quite as much as the hardware has evolved over time. So if you think back to the 50s and 60s with mainframes, with very extremely expensive computers, but the business decisions there had to be around trying to glean as much value out of those as you could. And that's not necessarily the case anymore, right? We've got phones that are as powerful. Interestingly, back to the extent that I'd said that our infrastructure world, our future is more of an and than an or, we've still got mainframes processing, millions of transactions a day. Anyway, so there's other issues here. Others have given talks, others have written free ebooks, actually, on the topic of unikernels. I'm, to the extent that I'm young in my journey here, I would point out free ebooks like that. I'd also point out some other talks that may give this, may do this better justice, but I'll just kind of highlight some, the problems that we're facing and kind of why it is that people are compelled to go to unikernels. So some of the ones that I just said, it's also security. If you consider the lines of code that are within the Linux kernel, if I'm not mistaken, it's somewhere around 2 million. That's large. That makes for a large attack surface. As you deploy a given distro like Debian or Ubuntu, I think that's on the order of like 4.5 million lines of code. That's tell me. In a Ubuntu distro, like a. No, just like Linux kernel. Oh, okay. Wow. Okay. Distro probably dwarfs that. Okay. So I've got a 0 off. So. You're understating your case. Okay. Very good. So it's worse than I'm painting. Okay. The other issue, I think, is, and tell me if this is true, but as you go to deploy a given operating system, you'll often find that maybe you're running package managers that are pulling in additional packages. Maybe you don't necessarily need. Maybe you're running additional services, and you've got drivers for, maybe floppy disks or USB drivers that you're not necessarily using, depending upon what your application is doing. So you've got these, risks lying around. So I'm going to iterate through some of the promises of unikernels. And I, for one, will certainly say, back to what I'd said before, that this isn't a panacea for sure. These probably make containers look like more of a panacea, but there's some really compelling use cases for containers. If we try to define and just come to understand what a unikernel is, I don't know if many of you know Ian, I forget his last name, the CEO at Defer Panic, ended up trying to give a definition back this last OSCON, and he'd said it was a way of cross-compiling applications down to very small, lightweight, secure virtual machines, essentially down to bootable images. Yes, sir.
Kernels with 15 million lines of code, 37,000 files.
Wow. Okay.
2011. What was that? The release of Linux kernel 3.0 grew 13 million lines 15 million lines of code then.
Impressive. And those, yeah, and that's actually a good kind of figure to hold in your head as you go to think about what unikernels can cross-compile down to. Some of them get into the kilobytes, which is, again, sort of game-changing. So if this is kind of our, the stack here, as you go to compile a unikernel, what ends up happening is you can essentially describe a unikernel as a library operating system. You end up going through a process by which only the necessary libraries that your application is using get pulled into what becomes a machine bootable image and what becomes a unikernel. Those are bootable, oftentimes people are running unikernels on hypervisors like Xen. Sometimes they're running them in VMs. I think you hear people argue that public clouds aren't necessarily the best place for unikernels, and you can certainly run them there, but maybe you only get so much of the efficiencies. And they're also bootable on bare metal as well. And so when you think about how small these are and how secure they are, IoT as a use case really comes front and center. So Raspberry Pis and other devices. This is arguably not all-inclusive, but is one perspective on kind of what the landscape looks like right now, both for different types of unikernels themselves, projects that are within the ecosystem, as well as, and kind of what ends up being described here often is sort of this general side of the house being kind of a, well, I'm gonna bastardize this probably, but it's the unikernels that you see on the general side are where you might be able to take an existing application and compile it into a unikernel. Those are POSIX compliant unikernels. And so conceptually, much of the code that you've written today is likely to work. That isn't always the case. But the language-specific unikernels are probably more where you would start with a clean slate and you would implement using one of those languages that they lead into. Interestingly, a couple of the projects here, like Jitsu, folks heard of that one? It's kind of an interesting project, but it's, was it just-in-time summoning? So it's a forwarding DNS server that, as it receives a DNS request, as it goes to respond back to the DNS client with the IP address of the server for that service, in that time that it's responding, it will invoke and spin up a unikernel to then service that request when the client comes back. So kind of a neat, start to think of kind of microservices in that way. So there's an improvement on security to the extent that there is no multi-user support in unikernels. It's a single user space, single address space. So there's really no passwords or authorization info lying around to be hacked. Many of the attack vectors that I had intimated towards with the larger operating systems are conceptually gone. So there's sort of this in-the-box security that happens by it being so much smaller. Really only the libraries that you need are linked and statically pulled in. So you're not necessarily sometimes folks will go out and turn off SE Linux or maybe not define their seccomp policies or their AppArmor policies until they've deployed it, and then they're going to in good faith come back and define those policies. But so anyway, there's just sort of more security out of the box. We also get to a point where unikernels might actually be the canonical representation of immutable infrastructure. Is that a familiar concept to most of you guys? Just the kind of pets and cattle stuff? Not at all. Yeah. Anyway, so kind of a quick reminder about microservices, what they're intended to be. Unikernels can really begin to look a lot like that. I think if you talk to folks about microservices and you're doing it in a containers context, you might, if you mention that you're running multiple processes in your containers, you might get slapped on the wrist for running more than one process in that container. Now that isn't necessarily the the wrong thing to do. There's absolutely call for running multiple processes in a container, but what you're going to find in unikernels is that they're going to want to run a singular process. So even things like SSH won't be there.
One good thing, when you're referring to the immutable infrastructure raises the question, how do you deal with state like with file systems and like that?
That's a good question.
Is that a separate thing?
Yes. It's a good question. I'll just repeat it just for the, so the question was, you know, when you're talking about immutable infrastructure, how do you deal with state? You know, or how do you store that stuff? You know, my understanding is, and we're going to see it with the UniK project here, is that you'll end up, you can statically link to an external volume, and in a similar fashion as you might treat volumes today with containers, you would do so with unikernels as well. Nice. All right, and then so there's some efficiency savings. There's probably some dollar savings as you go to share maybe high-end access to a system, access to a high-end system. You go to utilize that infrastructure more efficiently. So lots of promises. If we talk about UniK for a minute, or for the remainder of the talk. So UniK is a tool for doing that cross compilation. I think I tried to put it succinctly before and say that UniK is sort of like Docker for unikernels. It helps you build unikernels and deploy them. Now, it for the most part is wrapping the other projects that we were talking about. So it is leveraging the rump run and OSV and Mirage OS. It's really orchestrating, kind of pulling together the value of those other projects that we just saw, but it's just making it easier and putting it into the hands of mere mortals like me. So it is kind of akin to how Docker builds and deploys. It does have many UniK does have many what we're going to find that are called providers. So it does have many targets that it can deploy to, and we're going to look at what those are. It does compilation of these languages, at least currently. And like I said, it can target many different virtualization platforms. We're going to look at the specific ones. It incorporates, like I said, it's building upon the shoulders of other unikernel projects. It's a young project. It was first announced this last May. No doubt the team was working on it before then, so it's about 9 months old. The project itself is stewarded by these folks here. These are links to the Slack for the project, the Twitter, and the GitHub. The GitHub has some juicy details. The team is always highly encouraging of folks reaching out, engaging. I think the GitHub has about 1,200 stars right now, for whatever that means, and the Slack channel has just under 100 folks on there. So it's been growing. So there's kind of three major components to the project. One is this UniK Daemon. It's an API server. We're going to take a look at what its function is. There are compilers that UniK will take advantage of, like we just talked about. UniK supports the languages that are listed under those unikernels. And then it supports different providers. So to the extent that that it's building a unikernel, it needs to do so specific to your target, to your provider, to where it is that you'd like to deploy that container. And it needs to take into account what that form factor looks like. In the case of AWS, it could look like it looks like an AMI, a really small AMI. So some pretty decent set of integration there. Also, UniK has, if you guys are familiar with Docker Hub as a community exchange for pushing and pulling images that you build, the same deal is happening with this project. There's a UniK Hub. Currently, it is up and available. There isn't a UI to it, but it is cloud hosted. Right now it's AWS S3 backed. You can download and run on premises. If you do, out of the box, it's still going to want to push to S3. The project itself, like we just gone through those list of providers supported, but it also supports these two architectures. And when you think about the canonical use case, or kind of the sweet spot for unikernels that I'd said before, probably the world of the Internet of Things, the IoT, the support for ARM becomes important in that regard. The team itself has done some demonstrations of running unikernels on Raspberry Pis and cooking toast on the stage, and a couple of very interesting integrations in the cloud native ecosystem, if you will. So to the extent that, so it's Docker, Cloud Foundry if you can't read it, and Kubernetes. For the integration for Docker is such that such that the team understands Docker is on fire, and many people are coming to understand that CLI and that way of dealing with containers. And that's not legible, is it? And dealing with containers. And so anyway, the project UniK has an integration with Docker in that if you want to use Docker run or Docker PS, you can. You end up switching out you use the -h flag to point to the unique daemon, the API server that we had on the last slide. And so in essence, you can do things like Docker run and actually spin up UniK will spin up a unikernel in place of a container. So you can use, if you've invested in that interface and you've got scripts around it, you can still you can use that. You can't necessarily do Docker build though, because that's just such a different process for compiling unikernels than it is for building containers. So just kind of one caveat to note. UniK also integrates with Cloud Foundry as a runtime. So there's a unique Cloud Foundry build pack that you can take and install in your Cloud Foundry deployment, and that gives Cloud Foundry the ability to essentially orchestrate unikernels, which is very helpful for. That's kind of one area that we haven't necessarily talked about yet. Is that to the extent that UniK is helping you build and deploy unikernels, it's not necessarily sitting there ongoing, orchestrating and managing the unikernel. If you deploy the unikernel and it dies, UniK isn't sitting there, doing a reconciliation loop to make sure that it's up. So tools like Cloud Foundry really help with that. Not just Cloud Foundry, but Kubernetes as well. And so the integration here works in a similar fashion. So now that the team has done an integration with Kubernetes, not only does Kubernetes support multiple runtimes, container runtimes like Docker and Rocket, but also supports UniK. And so back to what I'd said before about the future being kind of and my belief that, hey, sometimes you're going to find that you're running VMs and containers together and VMs and bare metal together. And anyway, with this integration, you're able to run, or Kubernetes is able to run containers and unikernels side by side. Kind of nice. I will say this, it's, like I said before, it's a young project, so there are some caveats to this functionality, but I thought I would try to deliver on the promise before about walking through some, what the project looks like. How do you get it up and going? How do you install it? What do you need on your box? All very fresh for me. So actually on that topic, in order to get so I've got a MacBook Pro up here. I've got Docker on the Docker for Mac on the MacBook, which is actually important in terms of how it is that the unique binary that you use to build containers and deploy. To build unikernels and deploy unikernels. That make process for the unique binary leverages Docker containers. So just during the initial setup, you would need a Docker daemon, a Docker host present. So to get started, pretty simple. You go out to the GitHub URL, do a git clone on your box, go in, cd into that directory, do a make binary. It kicks off a long process of going out, pulling down different Docker containers, essentially building the unique binary specific to your environment. All really rather straightforward. Let me see if I can't walk you guys through this on the terminal. So to the extent that I've done that, and I've got the unique CLI, the unique binary. Let's start from there if we could. Yeah.
So are we developing a kernel or everything but the kernel, like all the libraries and everything to run that goes into Docker, or is this going to be something, as soon as you include the kernel, then you need to
Yeah, if I, so the question is, hey, what's the build well, part of the question is like, what's the build artifact that we're coming out with? So the process we're about to go through, we're gonna go write a very small Go HTTP server and use Go to run on. And then we're going to take UniK and tell UniK to build a unikernel that runs our small Go program. And the output that UniK will give us is a unikernel. I think it's about a 40 meg unikernel that, in this case, uses rump as the unikernel base. But yeah, the end artifact is like a 40 meg machine bootable image. And in our case, we're going to boot up that image. So we do have the choice with UniK of those different providers, AWS and OpenStack, and the ones that were on the list. But in this case, we're just going to boot it up on Virtualbox on my Mac. To your point, yeah. So going back real quick, so we've got the UniK. We built UniK. We've got the UniK binary on our box. We do UniK configure. And this is, everybody, this is good, right? This is large. So UniK configure, and it essentially asks us a series of questions around what our providers are, what our target systems that we might want to deploy to are. That becomes important because, well, I guess we'll get into that in a minute, but it's obviously important so that UniK can deploy to those environments. Also UniK, depending upon the environment, might want to deploy a small listener daemon, a small listener agent. We're going to see that it does that on Virtualbox as a way of the, boy, I should have diagrammed this out, as a way of the binary speaking into, in this case, into the Virtualbox environment, having a small agent to be able to really affect, spin up new VMs and affect that infrastructure. So not always a required component, but we'll see it here. So in this case, we're not going to do AWS or GCE or OpenStack or QEMU or UKVM. Oops. We are going to do Virtualbox. I pressed no. Let me go back. And so with respect to Virtualbox, two choices of the type of, and by the way, Virtualbox is typically used in like a development test scenario. And so, but two types of supported networking there, whether you were to use host-based networking or bridge networking. I think the recommendation is that you use host networking so that once your unikernel is deployed, it would be connected to your host network, and then that way you can just hit it directly, without. So I've typed in here host only, and then it wants you to type in, hey, what's the name of that network adapter? In this case, it's VBox net 0. And then we kind of go through saying, no, we don't have any other places that we want to deploy to. And what that ends up doing is, in your home directory, there's a small hidden folder. There's a small file called the Daemon Config. In this case, it's a very simple file. It just lists out what your providers are. In this case, we just set up, it gave it a name to VBox, and it's got the two choices, just really rather straightforward. One thing I will say that, and maybe I'll go in and kind of show it now. So I've got my Virtualbox here. And one of the setups that I've got is just that in the network, I've gone in and created a host-only network, and it's called VBox net 0. All I did was click the plus sign, and it created the network, and it's going to handle DHCP serving for VMs that spin up on that network. So if we go in and just look at that real quick, it's got a range from starting at 100 going up to 254. And so, okay, so we've configured our environment, which looks generally like this. Now we need to spin up the API server, that UniK daemon. So UniK daemon. In this case, we'll put it in debug mode, which is going to be probably horrifically verbose. But what ends up happening is that the daemon spins up. It sends out a UDP broadcast to find if there are any instance listeners, to find if there's any of those agents that I was talking about sitting. In this case, I said, hey, we configured the binary to use the Virtualbox provider. So it knows that, hey, it's looking for Virtualbox locally and wants to use that host-based networking that we gave it. It's going to go out and look for a listener there. If it doesn't find one, it's going to go ahead and create a small, it'll create a small unikernel and boot that as a VM. And it's going to be that, in fact, it did. This is just a small unique instance listener. Okay? So now what we have is that unique instance listener sitting out there listening on port 3000. So we're just going to leave that running as a daemon and just open up a new shell. All right, and then so since we've got it up and we're probably connected to the daemon, it's probably time to maybe just familiarize a little bit with UniK itself, so we just start, kind of fiddling with it. So, so obviously the CLI command is UniK. It takes these different commands. If we were to get familiar with the environment a little bit, we could run a UniK PS. Is that legible? I hope it is. And we do see one instance in there. If you're familiar with Docker, this kind of feels the same. There's one instance in there. It's that listener instance that we just saw. If we take a look at maybe what images, what unikernel images we've created in the past, if we have. Right now, we've just got that instance listener. If we take a look at what providers maybe we've configured, we've configured Virtualbox. And so you can just kind of run through these commands. I said that there was a UniK hub where you could push and pull unikernel images. We could do a quick search of the UniK hub. So we type UniK search, and it goes out to that hosted service. And there's not much in the community catalog. There's about 4 or 5 example unikernels that you can pull down and run locally to. Okay, so we've begun to familiarize with UniK. Let's walk through that developer workflow that we were talking about before. Let's make a small little Go HTTP guy and create a unikernel out of it and deploy the unikernel. So within my environment, we've got hopefully the smallest amount of code that we could possibly have for creating a Go HTTP server. So we've got our http.go, and we've got our Go dependencies defined. So if we go into http.go, very small set of packages. We're essentially just spinning up an HTTP response writer. We're writing out the smallest bit of HTML here, and so if we do a go run HTTP, I told the Go server to do that on port 80, or I'm sorry, 8080, to listen on port 8080, and so we don't have any issues in our syntax. Our code works. We can stop that HTTP server from running. Now what we need to do is go out and build a unikernel from that Go code. Step you guys through kind of this command here. Actually, I'm afraid as soon as I paste it, it's gonna. But yeah. So the command here is, so we're saying UniK build. We're going to give this particular unikernel image a name. I've just called it Go Calcote, just to encourage myself, I guess. And we're going to tell it, where it is to pull the Go code from, our local path that we're currently in, the HTTP guy. What unikernel base to use. In this case, we're choosing rump as the base unikernel. What language it is that we're using Go. And then where do we want to, we need to tell UniK as it's building this unikernel, what's the ultimate environment that you're looking to deploy this in, so that it builds it in an infrastructure conscientious way. Yep.
If let's say this was like a Java program and we'd have all sorts of dependencies. How does this know how to find the dependencies? I mean, I don't know how they work in Go, but I know that Java, typical production Java has lots of them.
Yep, so the question was, and this is one that I'm going to have a horrific answer on. The question is, hey, within Java, as you go to build your application, you've no doubt got all kinds of different dependencies. In this environment, in a unikernel environment, how is it that it knows which dependencies to pull in specific to your application? And I will say, I will not give that answer the best. I'm unqualified there, I guess is what I would say. Like that is some of the magic behind that. So part of the reason that I'm drawn to UniK is that it handles.
So you would say that it knows, it figures it out and gets them.
Yeah, there is some, like in specific to this example, there is for Go, the Go language specifically, there was this Go deps folder. So if we go into there, there's one file. It's the Go deps. It's a JSON file. So if you go look at that, this.
Speculation about Java, and that it probably gives you all the C libraries in order to run the JVM, and it's up to you to provide all your dependencies in a giant URL of your file. That would be my speculation. So there's no way it's going to know your Java.
Yeah, because it's like to have, I mean, it could have been done with Maven, and God knows what the hell.
Yeah, that's up to you to encapsulate it in whatever your war or your file.
Yeah.
My speculation is that the Java environment provides the C libraries required to run the JVM.
Okay.
Maybe.
But yeah, you need the database and a bunch of other things. But I guess okay. Well, okay. So what you're saying is that that's like would be a separate lecture on how we would get everything collected.
And in part, UniK itself leverages some of the capabilities that those unikernel environments have already. Like in this case, it's using rump as its base unikernel image. Those individual products, they do have the ability to compile into a unikernel themselves. UniK as a project is coming in on top to say, let me make this even easier for engineers to come in and use this, and add a lot of value around where to deploy to. But it absolutely like sits on top of the current capability. So I think like part of the answer is not necessarily even UniK specific. It's like, hey, the way in which those compilers identify which libraries are used by your application is.
Maybe calling in somebody else's services.
Okay, good. So so anyway, there's a Go dependencies file here, which does have a role in you identifying, where some of those dependencies are. So let me run this build command again. Okay, I'm in the wrong directory. Okay, so we executed the command that we just stepped through before, and it was just taking our simple Go file out of the current directory that we're in, building it for Virtualbox. It's actually executing that build in the other window here that I'm just running in debug mode. It generally takes about 30 seconds or so. Looks like it completed in 23 seconds here. It just built that small little guy, and so we gave it the name of Go Calcote. It's for the infrastructure Virtualbox. It's been created. It's of a size about almost 40 megs. If we take so now we've got, if we run the UniK images command, we see now we have two images. We have the one that we just built, that 40 meg guy. All right, so the next step is, hey, we built it, let's deploy it. Actually, yeah, well, it doesn't matter. I was going to make it a little more pretty, but we don't necessarily need to. I was going to add some things other than just a Go HTTP server, a little image, but that doesn't necessarily matter. So we built it based on what it had said before. If we want to go ahead and go deploy that, this is the command here. So it's UniK run. We're going to give the instance that we're spinning up a name, in this case just SCaLE x15. And we're going to say from what image should be used to deploy that new instance. And it's the image that we just made, the one called Go Calcote. So let me clear the screen here and just paste the UniK run, give it this name from that image, and did it pretty fast. The screen kind of goes off here, but what you should be seeing is that at the end of the line is the state is pending. So it's just kind of, you know, it received the command, it's processing, you know, spinning up the unikernel. Really, it's already done. So if we do unique PS, we should see now that we have that instance running. It spun it up in Virtualbox on that host network that we talked about before. We should be able to go to this IP address under that port 8080. And yeah, I was going to change it out with a pretty image, but hey, it's the... Anyway, if we go into our Virtualbox environment, we've got a new VM running, the 40 meg or the 39 meg guy, called SCaLE or SCaLE 15X. There are some things that the team, so to the extent that UniK is intended to help people do that build and do those deployments much more easily, part of the weak area for unikernels is like the ability to debug a unikernel once you've deployed it. So if it's a single process thing and it's a single process, multiple threads that you can run, and one of those processes isn't going to be SSH, because that would be a second process. You're not going to, so getting into it, to debug it once it's, so we were kind of going back to that immutable infrastructure, like the way that these things run don't lean very well into petting it and updating it over time, but it also creates an issue to the extent that you're running a unikernel, you're having problems with it, you need to debug it, what's going on. One of the things that the UniK project provides is a command called unique logs. Unfortunately, I don't think that this command works in my environment. We'll give it a shot. And so it's a simple command, unique logs, and you tell it what instance you'd like to get the logs from. Actually, I used the command wrong, so it's just instance equals SCaLE 15X. It does work in my environment. It pulled back the log saying that UniK was bootstrapping it, deployed it, got it up and running, got an IP address, which is nice because that's one way of getting at some of your standard out, your standard error. Another way that UniK provides that is if we go back to the unikernel itself, UniK will expose a port by default on 9967/logs. It'll spit out those same logs here. So.
Are you serious that only do one process? That's it by definition for unikernel?
That's my understanding, that there isn't a process manager included in the unikernel box, if you will.
That's true for all unikernels?
I will caveat that with I know as much as I've learned, in so much as I have learned, that's true. So with an ebook that I pointed out, Russell Pavlicek, who wrote it, and I quote, I guess the quote was there that he had said, hey, there are no functions for managing a process in there. So start, stopping, restarting a supervisor, if you will, a process super. So
there's no fork and exec.
Yeah, right. So.
On the other hand, something like this should be able to run on a Cortex-M because it's a single address-based device.
Okay.
Tell me if this sounds right.
You know what? I have to claim ignorance there as well. Yeah.
Those are really, really tiny chips.
Oh, okay. Okay.
I mean, like IoT kind of stuff.
I know the.
Are you saying that it would work on a single namespace?
Sounds like what you said.
It's not actually. That's right. That's a number in mind. Yeah, I haven't asked that, but.
That leads to my next question. Are unikernels based on Linux? Linux kernel?
They are. Yeah, well, these, where's the,
So it's unique to itself. It is its own kernel.
Well, it's not asking a question. It's an address for this machine. And that machine can have Virtualbox to that machine or a kernel.
yeah. I guess to answer the first part, back to the IoT use case where like unikernels could fit really well, is to be spun up on the metal, if you will, on the IoT device.
That's what I saw. That's really where it's and I guess I was watching some other presentation like 2 years ago. The intention was sort of to bring the old style of your own operating system so they can move to like a kind of
Mm-hmm.
that was the idea. Create an operating system that is close to run only one application. And
Okay.
this was sort of things. I mean,
Okay.
some of us may have networking background, I don't know, some of the networking devices do exactly like that for the last 20 years. They have like a all the operating system only does, network interfaces, packets from there.
Huh. And yeah.
When you ran the build, it only took like 30 seconds. So is UniK just linking compiled objects together? Because even if it's just a subset of, code from Linux kernel, libc and all these things, it would take longer than that, right? So it must just be linking together things that have already been compiled.
Yeah, I'm not going to venture.
Maybe that's what Rump does.
Yeah, I mean that would be my thinking. But the thing is the reason I didn't say that is because, or my belief is like, hey, that's Rump's responsibility. But I don't know if Rump is necessarily doing it, because it would have the same time-bound challenge as well. So I. There was kind of two ways that UniK helps at getting at some debug. One was using the UniK logs command, and then you just give it the instance name, and it pulls those over. So my understanding is that's doing it over that it's exposing this port here. It's for each unikernel, it ends up putting out opening up a UDP port on 9967, listening to the world. So this is which strikes me as like, hey, something you're going to want to be aware of and make sure that you've got the right security around. But I think the initial thought there is for debug. So you can hit it over HTTP as well. That same port, and it'll spit out the same logs.
Okay, if that's really useful, I mean, that can be a primary mechanism of getting the main recognition. I couldn't find it in the unikernel GitHub.
Oh, in the okay, yeah, yeah, but it's a pain area of unikernels in general, and so yeah, to the extent that they're helping facilitate that, I totally agree. Yeah. Mm-hmm. Yeah. And I'm again like I just wanted to be totally transparent with you guys about my level of knowledge. But it might also just be the case that UniK is facilitating a mechanism to retrieve logs, and then it might be up to your application. Like it might not be taking into account any common infrastructure metrics that you might expect it to. It might be that it's sort of up to you to spit out to standard error, things that you.
I know what you mean, but I don't know how you say put together something. But when you build it, you're going to generally say, I want this CTPI stack with my pipeline. I want this on the application is also going to like that. I don't think you want to write on the CTPI stack on you can just use whatever is available with small CTPI. So once you're already providing these common resources, and you have a college course getting persistent, I would think it would be very obvious use case to expose the cost of the TCP stack and sort of via that course. You don't think we'll be running the same stack and the same concept?
Yeah. Yep. I would think that are any of you guys familiar with Prometheus? Anyways, sort of within the cloud native ecosystem, a popular metrics tool, time series based metrics and it really wants to do that only over HTTP, and it really wants to pull the statistics. So this seems like a perfect way for a system like Prometheus to get at those metrics. Well, I am all tapped out, or there might be a couple other nuggets in there that I know, but yes, sir.
I just thought that what CTPI stacks up when you take it?
Yeah, that's good. Yeah, so yeah. I wonder if that isn't dictated by the choice of in this case of rump.
It probably has to be, because if you don't know if you're running on rump or something else, then you don't really know what you're plugging into. So I would imagine that you would have to communicate to whatever you're running that you need a TCP stack and you need this and you need that. So you could, in a way, I'd imagine that your build delegates a lot.
Mm-hmm. To the, yeah.
It knows how to translate into the other guy's makefile and say, make me something that does this. And it would then have to put together the stuff because, otherwise, you'd be so married to every single implementation, every single back end.
Yeah. Let me go back to the slide that talks about.
No. I mean, what I'm saying is that you would have to know, for example, you'd have to have the API compatible, or even lower than that, to everything that, let's say, Rump or Includos or MirageOS do. On the other hand, if there is a builder where you can tell it, I use a TCP stack that, what's that, like the Unix basic libraries, there's a name for that. It's the things you expect to have on it.
Mm-hmm.
So if you can identify those things, then you can delegate the make to the lower level guy, and you'll assemble it out of whatever pieces it's got.
It sounds like a compilation time.
Yeah, but the question is, it's a compiler compiling.
Yeah.
I mean,
yeah, that's right.
Orders, he says, I want to have something for Rump using Python.
Yep.
And then, either the UniK has to know everything about it, or there has to be, he simply has to know how to tell Rump to assemble enough pieces for that. So if I were designing it, I would try to delegate.
Yeah, that's right. Moreover, if you consider how quickly the project has come together, there's just this small handful of folks that have been focused on it full time.
Well, all the Social Security numbers for IQs.
Yeah, yeah. But yeah, I think it is generally the answer that hey, it is, And actually, the next project that this group is working on they've called it Layer X, and it's intended to be even further up the orchestration stack. And so, yeah, they're absolutely just leveraging the downstream capability. I mean, a compiler of compilers is that's kind of a. Well, thanks for the education, I guess, is the.
This is interactive and leading edge, so don't be surprised. That's how it goes.
Okay. Yeah.
I mean, I just thank you very much for presenting and for not.
Oh yeah.
I've been in places where people pretended to know more than they knew, and you certainly didn't do that. So, come back and tell us more next time. Okay.
Thanks. Good. Excellent. Oh, good. Oh yeah. It is just the URL at the bottom. Oh yeah. Yes. Thanks so much, guys. It was nice. Yeah.
build hypervisor, and when you build it, you don't just build the application, you do everything. You know, like the whole block is based on an image, and then you ship it out once. And we shouldn't get the veggie on the phone. That's the last resort. It should just be basically push executable out at once. So switching from that mindset to UniK is a step. The big stumbling block for us is that well, do we have these monitoring systems we get those learned? Everyone asking about the cause.
Okay, I've recently, I've used the word in a single address, and you can make this in simplicity if you spread.
Oh, it can be done.
He doesn't want to do it.
That could be a flag that you could put in. You could say, monitor following variables. You know, give me a temper, sort of thing. I'm going to give you keyboard.
This is like when someone could write estimates, like this takes estimates and takes statistics and then implements that in unikernel what. And we've already got code that can fuck up the estimates has been around forever, like 10 years.
Not longer than
And so that would be one vector for people to say, okay, so you can say deploy unikernel and you can also do like all your ancient software problems solved anyway. So suddenly they become more palatable and can get their own environment.
Like Netflix advertises they use microservices. How do they define microservices and Netflix?
In application specific function. Now, if your question is, how do microservices come into being? Like, what is the thought process when an engineer says, that should be a microservice? That's something that's often debated. No one's really sure. But when microservices happen, they are a specific application now.
Okay. And it's a different word everywhere. Different people have different interpretations.
So that, then you just distribute them on the hardware, and they know who to listen to and they know where to go.
It's called Trireme, and it does a lot of what you just said from a network level. It ends up allowing you to define in config file which, in this case, it's in container.
Yeah.
But which containers you want to be able to allow to speak to other containers.
Who can say what to whom is, because I went to a number of the presentations in IoT, and it's like I haven't slept that night, with all the security fears. I mean, but this looks like this could handle a lot of the stuff. I mean, you could essentially compile something that says this goes into the chip with this network. All the chips have like these serial numbers.